Hello there, welcome to this tutorial on rockets. So if we have a rocket, let's have a rocket like this. So you got this brilliant rocket, that's a fantastic rocket. What we want to look at is the one-dimensional propulsion formula. So for one dimension like that. So what we want to do now, we want to basically start by looking at the momentum. So we know momentum is P, I apologise for my handwriting, is equal to mass times by velocity. So we know the momentum beforehand, P before, is equal to mass times by velocity. However, if you think about it afterwards, it's going to have, the mass is going to add dm, and the velocity is going to add dv for every tiny little change. So we know that the momentum after is going to be equal to, or at least part of it, the rocket part of it, is going to be equal to mass add dm, and then velocity add dv. That's part of it. However, it's not the only part of it. We also want to take into account the mass coming out of it, and that's going to be rejecting from the rocket at minus dm because it's going downwards or the other way. And then you also have to consider the velocity, the relative velocity. So we know the fuel is going to equal the velocity of the rocket in one dimension minus the velocity of the mass leaving. So I apologise, that's a really bad U. Let me just rub that out. Minus the U value of the fuel leaving. So you've got the velocity of the rocket, and then you've got the fuel leaving at U speed, or velocity, not speed. And then once you have that, you can get the full equation by equating the momentum before and after. So you have, let me just put this here, mass times by velocity is equal to mass add the dm, and then you got velocity add dv. I apologise again, my handwriting isn't the best, I'll be honest. Add minus dm times by velocity minus u. It's not the best, it's not the clearest, and you can't see all of it, but you can see there is that part there. You can't see all of it there, but it's hopefully clear there. You've got the mass times the velocity at the beginning, and then you got the mass plus dm for the new side of the rocket, because obviously it's losing mass, so it's going to be every incremental, this is basically every single dt change. At every incremental dt, you're going to have a new mass and a new velocity, and you're going to have a new value for the fuel. So once you have all that, you can then times it all out, and when you times it all out, you get it into a certain formula. So, 1 second. Yeah, once you times it out, you get it into mass times velocity is equal to mv plus mdv plus vdm plus dvdm, and then minus dm. For the fuel part, you're going to have minus dm times by v, and then plus u dm. And then with this, you can cancel things out. You see that cancels out. You also see that velocity, that part is going to, VDM is going to cancel out with that, and you're going to get into a final form, which is going to be 0 equals mass times by dv plus u dm. And once you get into that format, we can then rearrange it to get it into a new format, which is mass dv is equal to negative u dm. And then with that, with that you can get it into a form of dv is equal to minus u dm over m, like that. And with that, you can integrate between v0 and v. dv is equal to minus u, the integral between m0, which is that's the initial velocity, initial mass, and m, and then you have dm over m. Now, when you integrate that out, you actually get into this form, which is velocity minus the initial velocity, and obviously with 1 over m, the integral of 1 over m is ln of m. So you can get it into a new format of negative u negative u ln of m, and then between m0 and m. Now, once you get into that form, you can do velocity minus the initial velocity is equal to minus u of ln of m minus ln of initial mass, like that. And once you get into that form, hopefully you can see that, you get into that form. Then once you get into that form, you can then obviously reverse that with v minus v0 is equal to u ln of m0 minus ln of m. And finally, we can then get it into the form of velocity is equal to, velocity minus v0 is equal to u ln of m0 over m, like that. And that's the final form. However, you can obviously give it an even nicer form by putting velocity is equal to the initial velocity plus u times by ln of m0 over m, and that is the propulsion equation. I do apologize again, my handwriting really isn't the best, but that is the propulsion equation for a rocket in one dimension if you don't include gravity.